I'm out here checking out an cabin altitude pressure switch, which I just did, but I did want to explain the functions of ram air pressure and static pressure, static vacuum if you want to call it, on an airspeed indicator. Airspeed is a function of ram air pressure from the pitot probe and static pressure from the static ports on the side of the airplane. IBSI is strictly static. Altimeter, of course, is strictly static. In this case, I've got my vacuum pump on and pressurized. All valves are closed right now, except for the IBSI. But what I'm going to do here is I'm going to open up the vent on the airspeed side to ambient. With the crossbleed closed, and I'm going to start putting a vacuum on the altimeter. You see a corresponding rise in the airspeed. Now if I go to about 3,000–4,000 feet, I'm going to peg out my airspeed indicator on the high side. You can only go up, like I said, 3, 4, maybe 5 until you've taken your airspeed to maximum. What I'm going to do now is go close this and vent static back to ambient. You can see my airspeed is falling. Watch my vertical speed. The only thing I exceeded, digital equipment can handle pretty massive hits, but this is an old analog box. I'd rather not pick it up. We'll go ahead and keep this going. And we're basically back down to 0. Now if I wanted to go to 35,000 feet without pegging out the airspeed indicator, the easiest thing is just open up the cross feed, and that bleeds a vacuum over onto the ram air side. Good, close that. Okay, this control valve from that tank is closed, and that's now closed, or will be. So I've got the cross feed open, and now let me put a static on it. What doesn't the airspeed do? It does not move. The reason being, there is no difference in pressure from the ram air side to the pitot side, the pitot side to the static side, and correspondingly the airspeed indicator never comes off of 0. I can safely take an airplane to 35,000, 40,000 by bleeding a vacuum over onto the pitot side, and you can check out pretty much everything safely without blowing any components. Digital air datas and digital components now pretty robust, but old analog equipment is not. It's got mechanical bellows in it, and mechanical bellows can take a hit and rupture. So in this case, we're not going to be damaging the pitot, whatever it is, an old analog air data or an old airspeed indicator, by keeping the two sides equal. Now if I was to close the crossbleed right now as we're climbing, a little bit more of a climb, there goes the airspeed. So we don't want that when we're going to high altitude and we got a pitot system or an airspeed system hooked in. All I'm going to do is open up that crossbleed to equalize those pressures, and we're good. Instead of keep on climbing here, we'll stop that and we'll go ahead and start coming down. But that needed to be explained so some people understand the basic functionality of a pitot static box, especially when it comes to ram air pressure. Thanks.